Yeah, so tell me in the last session what topic we discussed. Anyone, can you please remind me? Yes, what is the last topic that we covered?
Tail recursions and
Right.
not one, yeah.
Yeah. So today maximum I will try to wind up by taking some 15 to 20 minutes. We will see some one or two applications. But before that, let me revise what are the topics that we discussed in the last session. So in the 2 days demo session, so we have seen why we need to go for the recursion. So what is the importance of this recursion? So next, how this stack is going to play a role in the recursion. So next, what is mean by finite recursion and what is mean by infinite recursion also we have seen. So then even we discussed about direct and indirect recursion also, and very important, tail recursion and non-tail recursion also we have seen. So anyone describe what is mean by tail recursion with a single point? Anyone? So what is mean by tail recursion?
It is the
Right.
last action.
Yeah, very good, very good. So after a recursive call, if we are not taking any instructions, so then it is called as what? Tail recursion. So after recursive call, if we are trying to take any statement, then it is called as what? Non-tail recursion. So base condition also we have seen very clearly. So what is mean by base condition? If we want to terminate a recursion at a finite number of steps, then we have to go for this base condition. We need to write a proper base condition to terminate our recursion program perfectly. So, and even we started implementing the programs by using this recursion. What is the first program that we covered? So you can see how to print the characters present in the given string, like traversing the string in reverse direction. Like if you are giving any string, so how to print the characters from the ending we have seen. So after that, we have seen a program to print the characters in forward direction. See, whenever reverse and forward directions are coming, then we have to use this recursion concept. So recursion stack, these things will best choice for this kind of traversing. So after that, so we have seen very clearly like how to generate Fibonacci number and how to generate nth Fibonacci number. That state space tree also we covered very clearly in our last session. So these are the 4 applications what we covered in our previous sessions. So I hope everything is very good for you, right? So if you are having any queries, please let me know so that we will go for next 2 more applications. Clear? Any questions?
Clear, sir.
So please confirm everyone. Clear? Yes, right. So today, just we will see some 1 or 2 small applications. So what is the next application that I am going to demonstrate here is, so 5th application. See, I want to calculate sum of digits or sum of n natural numbers. We need to implement a program to calculate the sum of n natural numbers. See, first let me analyze by taking some test case. If n is equal to 5, tell me how you can able to add. So 0 plus 1 plus, so 2 plus 3 plus 4 plus 5. Tell me what is the result. Please confirm.
15.
15 now. Right. So you can see there is some pattern. See, some students asked even in the yesterday session. So when we should go for this recursion? If there is a common pattern that you can able to observe, so in such cases we can use this recursion. So you can see 0 plus 1, just we are adding these two numbers. So whatever result we are getting, that result we are adding to the next number, that we are adding to the next number. Whatever result we are getting, that we are adding to the next number. So and so on. That means what? So we have a particular pattern is there. Based on that pattern only we are executing. Even in the previous program also we have seen such a type of patterns, right? So in Fibonacci sequence there is a pattern like we are adding previous two numbers. In Fibonacci sequence also we are adding previous three numbers. So even while traversing the string in forward and reverse direction, so character by character we are increasing, I mean index by index we are increasing or we are decreasing like that. So here also there is a common pattern. Now we need to observe this pattern and we have to write the code. So can I write a formula like n plus? So we are calling a function by passing n minus 1. Is this formula is sufficient? Please confirm. Is it correct? So whatever n value that we are passing, it is keep on adding cumulatively. Like if n is equal to 5, 5 plus function of 5 minus 1, which is nothing but 4. Then again 4 plus function of 4 minus 1, 3. Like that it is going to take. If you are clear with the logical part, so I'm going to implement this in program. Are you clear up to this? Yeah, please confirm. Is the logic is clear?
Yes, sir.
Right. See, I'm going to define a function like fun of n. So when we have to stop the process, if the value of n, whatever we have given is 0, then simply I'm going to return the value 0. Otherwise, what you need to do? So we have to return n plus, just I'm calling the same function by passing n minus 1. So state space tree, just you can draw. So you can see the previous examples, whatever we covered. Based on that, you can draw the state space tree. So if you are unable to draw, don't worry. In the next session, I will draw the diagram. So as of now, I'm not in a position to draw. So you can see print off, just I'm trying to call a function by passing the argument as a 5, or let me take 6. So what is the expected output? Already for first 5 natural numbers we got 15. So for that we are adding 6. So the expected output is nothing but what? Tell me, what is the expected output?
21.
Right. So let me check whether we are getting that expected output or not here. So tell me which command we have to use to run the Python program. I forgot anyone. Can you please remind me?
PY.
Good. So py space test.py, you can see. So some of these natural numbers, whatever we got is nothing but what? 21. Like this, we can calculate. So sum of n natural numbers. Okay. So what is the output that we got for this program? 21. Do you have any queries up to this? Please confirm. So a simple logic to calculate sum of n natural numbers. Right. So the next program I want to do, so multiplication of n natural numbers. I want to do the multiplication of these two, I mean n natural numbers. So it is same like previous program, but a small change in the logic. What is that change? So here for n is equal to 5. So we have added starting from 0, but now since it is talking about the multiplication, so we have to perform this multiplication. But we should not multiply from the 0, because 0 into 0, that's why we can't do that. What is the result? 120. Here also common pattern is there. What is the pattern? n into function of n minus 1. Is it correct? Please confirm. This is
Yes, sir.
to please confirm. Clear up to this?
Yes.
Right. So now let us apply this in the program part. Almost same code. When n is equal to 0, instead of returning 0, we have to return 1 and n into function of n minus 1. And here I am passing 6. So what is the result? 6 into 5 into 4 into 3 into, so 2 into 1. Like this we are going to get. Let me run and check what output we are getting. 720. Sir, is it the factorial or not? Yes, same program. So if anyone is asking how you can able to calculate factorial of the given number, this is the code. Just what we are doing, we are multiplying these numbers. Someone is asking, sir, can I use n is equal to 1? Can I return directly n? Yes, you can take, but the problem is, so if you are taking n is equal to 1, suppose if user is giving input as 0, so what is the 0 factorial? So we can't print, right? That's why 0 factorial basic math rule. What is the 0 factorial value? 1, right? That's why let us take it as a default. I hope you understood, right? Yeah. Sir, any questions on this program? Please confirm.
No, sir.
Is it clear?
Yes, sir.
Yeah. So let me discuss one more application. Maybe that is the last application for today's session. What is that application is? I want to multiply, so two numbers. I want to multiply two numbers. By using recursion, I want to develop a code. For example, so let me take A is equal to 2 and B is equal to 3. So my requirement is A into B and 2 into 3 is nothing but what? 6. So how you can do this recursively? So 2 into 3 means we have to add 2 how many times? 3 times. That's all. Logic is very simple. Okay. So we are going to call a function by passing A comma B. What is the A value here? 2. Let me take A plus function of A as it is we will pass, but B value keep on reducing, right? So when B is equal to 3, what will happen? So 2 plus a function of, so 2 comma 3 minus 1, 2. Next again this function of 2 comma 2 will become what? So 2 plus function of 2 comma 2 minus 1, 1. Then again this one will become what? 2 plus function of 2 comma 0. So when 0 came, simply I am going to return 0. So what is its value? 6. So I think how we framed this logic is also very clear. Any questions? Is the logic is clear? Please confirm.
Yes, sir.
Right. So let me implement a program for this. So I will take a function like mul of a comma b. So if the value of b is equal to 1 or if the value of b is equal to 0, so simply return 0. Otherwise, I am going to return a plus multiplication of a comma b minus 1 I am taking. Now, if you print multiplication of, so 2 comma 3, what is our output that we are expecting? 6. Let me check whether that 6 is coming or not. Yes. Sir, everyone got clarity how it is functioning? Clear, guys, the coding part? So now my question is, tell me how many method calls happened in this particular function call? How many times we invoked this function? Can anyone please confirm? How many times that MUL function is invoked? Approximately. You can ignore the last case. How many times?
2 times.
2 or 3? 3 times, correct?
3.
And we have a basic mathematical rule is there. Whether it is A into B or B into A, the result is same. Am I right? Correct?
Yes, sir. Idempotent.
Yes, very good. So to just to make sure that that particular number of method calls we are reducing. Why? Because in the beginning itself, I told the biggest disadvantage with recursion is nothing but what unnecessary stack space will be there, right? So to avoid that, what we are going to do, just I am going to write a bit tricky code. Let us see what is that code. So print of MUL of, if I take 3 comma 2 also, output is a 6. But in this case, what will happen? How many times it is going to run? 2 times. How many
2.
method calls will be there? 2. Can I reduce this? If it is the small numbers, then okay. For example, consider here I am going to take 10 comma 2. So your output is nothing but what? 20. How many method calls will be there? 10 method calls. Am I right? Sorry, 2 method calls, right? So in this case, what will happen? Or let me take 2 into 10. In this case, how many method calls? 10 method calls. Now I am taking 10 into 2. In this case, what will happen? Same output, but how many method calls? Only 2. Output is the same, but unnecessary space we are misusing. So how you can avoid that? Here I am going to add some extra condition. What is that condition is? If B is equal to 0, return 0. Otherwise, if the value of A is less when compared with the B, then what I am going to do is simply I am going to return multiplication of B comma A. Whether it is A comma B or B comma A, the result is same, right? That's why I am just observing smallest number. If A is the smallest number, then I am changing that to the second parameter. Why? Because biggest number is there means what will happen as a first argument. So we will get less number of method calls, right? That's why. Are you clear with that this particular logic? Correct?
Yes, sir.
So what is the biggest advantage? Just we are trying to reduce the number of calls. Beyond that, nothing. Clear, friends? Sir, understand? Now, so let me check whether it is working or not. You can see 20 and then 20. So this is the way how we can multiply. So 2 numbers. Up to this, do you have any queries? Please let me know. Yes, up to this, any queries? Right. So with this, I'm going to conclude today's session. So remaining applications, we will continue from Monday. So this is the last demo session. So again, I'm repeating, it is a DSA with the Python. Fees is 3000. So you will get a live classes plus running notes and also recording. But the actual timings of the session is 8 p.m. to 9 p.m. on weekdays. Okay. So that's all. If you are having any queries regarding the course, you can ask me. This is the last demo. From Monday onwards, the regular classes will be there. Any queries from your end?
Sir, if we are not able to attend one day session, you said recording will be available. Will it?
Yes, I told, right?
Yeah, will it be available on Google Drive as a file that we have to download?
No. You can't download. Just you can play and you can watch.
Okay, play
So
and
it is
watch.
not downloadable. Once if the
Okay.
class completed on the same day, they are going to upload. Okay.
Okay, that link will be constant, right, sir? Because
Yeah, that link is a constant. Whatever email ID you are giving, for that email ID, they are going to assign a shared folder. Just you can
Okay.
open your Google Drive and you can check in the shared folder.
Okay.
Automatically you will get that.
Okay.
So it
Okay.
is a fixed, it won't be changed.
Okay. And in the weekends, what what will be the approximate timing, sir? I mean, at what time approximately class will be there?
Probably in the evening only. So around 2 hours, 3 hour session will be there sometimes. So hardly 2 or 3 weekends like that we will take, sir. That's all.
Okay, it will be from
Easy
6
topics.
p.m. or 5 p.m. like that, or
Maybe 1 hours before we will start. So 1 or 2 hours later we will start. Approximately it will be plus or minus 1.5 hour like that, sir. See, our
Okay.
timing is 8 p.m., right? Maybe 7
Yes.
p.m. or 6:30 p.m. like that I will start. Okay.
Okay. Okay. Yeah.
Clear?
Okay, sir. Thank you. Yeah.
Any other queries? Yes, from your end, so that we will wind up.
Sir, that Google Pay number, yesterday I saw in the chat that it was different, and the mail they mentioned the different Google
Yeah,
Pay
no
number.
problem. Both are same only. I mean, that both accounts are DurgaSoft accounts only.
Okay, we have to pay and send screenshot to them, right?
Yes, you need to pay and you need to send the screenshot to the given mail ID.
Mail ID.
So,
Yeah.
yes. So within 1 or 2 days, they will maximum 24 hours, they will give response. And Monday morning, you will receive the original class Zoom link. Okay.
And sir, no need to change the mail. I mean, this registration ID, right? In Zoom, because I am also registered with other classes in DurgaSoft.
No problem, no problem, no problem.
Yeah, it should be having some format like square brackets and
Not required, not required.
not required. Okay. Okay. Yeah. Okay, sir. Thank
Okay.
you. Yeah.
No queries, right? Yeah. Right, guys. Thank you. So we will continue from the Monday. See you soon. Thank you.
Thank you.